I find that working through examples for composite and inverse functions is usually the easiest way to learn them. So let's just dive into a problem together. Say we've got two functions, f of x is equal to x squared, and g of x is equal to x plus 5. So one is a quadratic function, one's a linear function. We're asked to come up with the composite function f of g of x and a second problem, g of f of x. We use this really weird notation, f of g of x. It kind of looks like fog, so sometimes I'll say fog x as like a little shorthand abbreviation for f of g of x. But really what this means that we're doing is we're taking the function g of x and we're plugging it into f of x. So from that previous point in the video, we're creating a function kind of within a function. So this is another way that's maybe a little bit simpler or more intuitive to write. And with that, well, let's just go ahead and plug it straight in. We know that g of x is equal to x plus 5. So whenever I see a g of x here, I'm going to write f of x plus 5. That's my g of x. So I'm literally just substituting what the actual function is for the g of x label. With that, well, the next step is pretty simple because we know whenever we have f of something, we have to plug that something inside the function, in this case, x squared. So if I plug in an x plus 5 into wherever I see an x term in the new f of x or the original f of x function, I'll rewrite it here. F of x plus 5 is just equal to x plus 5 squared. That's it. I know it seems maybe simple, but this is now the composite function f of g of x. Boom. Composite function in the back. Pretty simple. You could, in theory, IB could then ask you, okay, we'll expand this out or put this in a different form, but just to come up with the composite function, that's it. Let's look at the second example. What about the opposite way around? G of f of x. Let's rewrite this in the other form. G of f of x. Well, just like we did earlier, all we're doing is we're taking the f of x function and plugging it directly into the g of x function. So instead, I'm going to first write this as g of x squared because I know that f of x is equal to x squared from the previous or from the original problem statement. Well, if I take g of x and I plug it into the, or x squared, sorry, and I plug it into the g of x function, I end up with let's rewrite it. G of x squared is equal to x squared plus 5. Literally plugging an x squared in wherever I see an x. This, my friends, nice and simple, is our composite function g of f of x. That's it. So you're literally taking a function and plugging it into a different function wherever you see the variable x come up. All right, slightly trickier example. Now we've got two functions. F of x is x squared plus 1, that's our quadratic function, and g of x is sine x, so we're dealing with a trigonometric function. Not a trig unit right now, we're going to get to trigs soon, don't worry, but for the time being, can we figure out how to make two composite functions out of these two? Well, let's start with the one on the left, f of g of x. I'm going to rewrite this in the notation that I prefer, f of g of x. So I'm plugging g of x into f. Okay, well, I know that g of x is equal to sine x, so I'm just going to rewrite this as f of sine x. You don't have to do this. You can skip this first step. I just prefer to do it just for the sake of clarity. Once we're here, I'm going to take a sine x and I'm going to plug it in everywhere that I see an x term in that f function. So there's an x squared, but there's only one time where the x comes up. So I'm going to rewrite this then as f of sine of x is equal to sine of x squared plus 1. Well, if you've already taken your trig, you know that you could stop here, or you know that you could rewrite this in a bit more common notation. Usually whenever we have a sine squared function or some kind of trig function, we'd write the squared like this. Oh, that looks like a bit of an ugly one. There we go. Boom. And if you also have already done your trig, you're familiar with your trig identities, you know that you could simplify this to cosine of squared of x. You don't have to. In fact, stopping here would be totally fine for the time being if we're just practicing our composite functions. This is technically our most simplified version of this. It looks the prettiest, but either one of these are totally fine for the time being. So I'm going to put a little smiley face. We're happy little campers just for now, okay? Composite function f of g of x. Let's change colors and move on to the other side. What about g of f of x? Same thing. I'm going to rewrite this as g of f of x like this. Well, I know f of x is x squared plus 1, so I'm going to rewrite this as g of x squared plus 1. Then I'm going to go and plug in x squared plus 1, wherever I see an x in the g function. So for that, I get the sine of x squared plus 1, and that is going to be equal to my g of f of x. And for this one, no further simplification is really necessary, so we can just leave it like this. And there's your composite function. That's it. All right, last example. This one's a little bit trickier, not because the math is any harder or composing the two functions is any more difficult, but because the functions are just a little bit more annoying. There's a bit more to take into account or a bit more to keep track of. But we're going to do it anyway. So we got two functions. F of x is equal to e to sine x plus cos x, and g of x is equal to e to the x plus 1. Same thing as earlier. First, we're going to start off with f composite of g, or f of g of x. Let's rewrite this in this slightly more intuitive form. Then we say, okay, well, I know that g of x is equal to e to the x plus 1. So I'm literally just going to plug e to the x plus 1 wherever I see an x term in my original f of x function. So that's going to be equal to e to the sine of e to the x plus 1 plus cosine to the e to the x plus 1. Looks weird, but hey, guess what? That is literally, in fact, I don't even need to rewrite this because you guys know already. Let's take this, erase back to here, and that is our composite function f of g of x. Nothing crazy about it. Let's move on to the other one, g of f of x. We're going to rewrite this as the g of f of x. Beautiful. Now, let's plug it in. We know that the f of x is this annoying thing, e to the sine x plus cosine of x. So we're going to plug in that wherever we see an x term in the g place. That's literally what just a composing or a composite function is. So, well, I'm going to rewrite this as e to the x plus 1. There is the original function, right? So I'm going to plug in or substitute this e to the x sine x plus cos x for that x. This is the one that becomes a little bit more difficult to see just from experience. So here we end up with an e to the, be careful, e to the sine x plus cos x plus 1 is remaining. You're unlikely to see something this weird come up, but it's a nice little example to show how the embeddedness of the fractions or the functions looks. That's it. This is the kind of the hardest problem they can throw at you, or style problem, when there's a lot of e's and sines and all sorts of weird trigonometric and exponential things floating around, but you can handle it because following the same easy steps is always going to work.